We're going to continue talking about systems of linear equations and their solutions. There's a different method for solving these besides the substitution method, and it's called the elimination method. So to solve a system using the elimination method, we try to combine the equations using sums or differences so that we actually eliminate one of the variables and we can just solve for the one variable that's left. So here is the step-by-step process for the elimination method. First, we're going to multiply one or more of the equations by an appropriate number so that the coefficient of one of the variables in one equation is the negative of the coefficient in the other equation. Therefore, when we add them together, we get 0. We'll add the equations, we'll get 0 for whichever one that we manipulated to make sure that they have the same coefficient but opposite signs, and that will leave a remaining variable. We will solve for that remaining variable and then back substitute that value that we found into the other equation. So let's use these two equations, 3x plus 2y equals 14 and x minus 2y equals 12. Since the coefficients of the y terms are already negatives of each other and they have the same coefficient of 2, then all we have to do, we don't have to do the first step by multiplying anything to manipulate one of these equations. We're ready to go ahead and add them together so that we can eliminate them. And the way that you add them is just draw a line underneath them and add or subtract down. Copy down the equal sign, and then you're going to add every pair of corresponding terms. 3x plus x equals 4x, negative 2y plus 2y equals 0, and 14 plus 2 equals 16. Therefore, 4x equals 16 and x equals 4. So now we've found the solution for x, and we'll back substitute that value into one of the two equations that we're working with. We'll substitute it into x minus 2y equals 2. So if x equals 4, then 4 minus 2y equals 2, and therefore y equals 1. So the solution to this system is the point in the plane 4, 1. And you can see here's the graph of that. It is the intersection point of those two linear equations. So recall from the last lesson on the substitution method that there are different types of solutions. We can have one solution, no solutions, or infinitely many solutions based on what's happening to these lines in the plane. And so based on what we get out of our solutions, we're going to determine whether we have just the one solution or repeated solutions, infinitely many, or none at all. So let's look at this system. 3x minus y equals 0, 5x plus 2y equals 22. So the coefficients to x are not the same. The coefficients to y are not the same. So this is one where we're going to have to do some manipulating to try to get the coefficient of one of these variables to be opposite in sign and the same coefficient value so that when we add them we get 0. So if we look at equation 1, we already have a minus y, so we could multiply both sides of this equation by 2, or every term in this equation by 2, and that would give us a negative 2y for this term. So 3x times 2 is 6x, negative y times 2 is negative 2y, and 0 times 2 is 0. So that's where we get this. Now we can eliminate the y variable and just solve for x, and we find that x equals 2, and then we back substitute into one of the equations and we find that y equals 6. So we have the point 2, 6 as the intersection of those two lines, or as the solution to these systems. So let's look at this system of equations here. 8x minus 2y equals 5, and negative 12x plus 3y equals 7. So we want to get the coefficients to either x or to y to have the same coefficient. So we can work with the x's, we can work with the y's. We're just going to have to multiply by a positive value. If we multiply the top equation by 3, that would give us 24x. and then minus 6y, and then 15. And then if we multiplied the bottom equation by 2, that would give us negative 24x plus 6y equals 14. And so we eliminate the x's. It turns out in this situation we also eliminate the y's, and we wind up with 0 equals 29. This is what it's going to look like for us to have no solution. These two lines are actually parallel. They do not touch each other in the plane, or we would have gotten a value for one of those variables. So this is not a true statement. It's never true that 0 equals 29. Therefore, there is no solution to this system, and that's what that would look like. All right, let's work one more example. Here we have 3x minus 6y equals 12 and 4x minus 8y equals 16. We want the coefficients to be the same, so let's multiply the top equation by 4 and multiply the bottom equation by 3. So we get 12x minus 24y equals 12, equals 48, and then we get 12x minus 24y equals 48. Well, these two are the same. If we were to add this, we would get 0, 0, and 0. And it's always true that 0 equals 0. So this system has infinitely many solutions. This is actually, these two lines, these two equations are the same line. So that's what it looks like to get infinitely many solutions. So come to class next time and we will practice the elimination method for solving systems of equations.